Today I'll be going over question 24 from Energizing Physics Lesson 4.4. So the first part of the question asks what the acceleration of the box is at 2 seconds. So I'll just note that as A2. So we're given this data table that tells us the corresponding velocities at different times. And we know that A, the general formula, is delta V over delta T. And the acceleration at 2 seconds falls under the period between 0 seconds and 3 seconds. So that's from the second data point to the first data point. And it's given that during this period, the acceleration is constant. So we can just use this to find the slope, or the delta V over delta T for the acceleration. So the delta V is going to be 7 minus 1, and the delta T is going to be 3 minus 0. And that's equal to 6 over 3, which is equal to 2 meters per second squared. The next part is to find the acceleration at 4 seconds. And we're going to use the same general formula of delta V over delta T, only the period at 4 seconds falls under the second period. So we're going to use the third and second data points. So that's going to be 1 minus 7 over 5 minus 3, which is equal to negative 6 over 2, which is equal to negative 3 meters per second squared. Part B of the question asks for force diagrams. So we want to find the force diagrams at both of those times, 2 seconds and 4 seconds. So we'll use the acceleration at 2 seconds to help us with our force diagram. We know that F net is equal to m times a, and we're given that the mass is 25 kilograms. So F net horizontal is equal to 25 times 2, because we solved for acceleration at 2 seconds in the previous part, which is equal to 50 newtons. So we know the F net horizontal, but we just want to find the two components. And we know that Evan is dragging the box, so there's one component that is Evan dragging, but there's also friction. And we're given that the coefficient of friction, mu, is equal to 0.4. So we have the equation that force of friction is equal to mu times mg, because mg is the normal force. And what we can do with this is force of friction is equal to 0.4 times 25, which is the mass, times 10. And that gives us 100 newtons. So we then know that the force of Evan minus 100 is equal to 50, because that's the net force, and friction is opposing Evan's force. So F Evan is equal to 150 newtons. So now that we have the horizontal components, the force diagram, if this is the box, we'll have one component this way, which is F Evan equals 150 newtons, and then F friction is equal to 100 newtons, and then the downward component of gravity is Fg equals 250, and then therefore Fn is also equal to 250. So that's part A for the force diagram at 2 seconds. Now we're going to do the force diagram at 4 seconds. So in the part A, we found that the acceleration at 4 seconds is equal to negative 3 meters per second squared. So again, we use F net equals ma, which is equal to 25 times negative 3, which is equal to negative 75 newtons. And we know from the previous part that we already solved force of friction is equal to 100 newtons, or negative 100 newtons if we consider the direction. So now we just have to figure out the force of Evan. So force Evan minus 100 is equal to negative 75. Therefore, the force of Evan is equal to 25 newtons. and then we can draw the force diagram. So Evan's force, F Evan, is equal to 25 newtons. Force of friction is going to be 4 times as large, equals 100 newtons, and we still have the same vertical components where F gravity is equal to 250 newtons and F normal is equal to 250 newtons. Voila.